Okay, everyone, what if we had this question? What if we were given the function h of x, it's equal to 3 times x plus 1, and what if we were asked for what value of x is h of x equal to 13? How could we figure that out? Well, we know two things. We know that h of x is equal to 13, right? For our question here, we know there's a formula for h of x in terms of x. It's 3x plus 1, right? So we know that if h of x equals 13, 3x plus 1 equals 13. Can we find a value of x that makes that true? Yes, we can by treating this as an equation, right? And solving for x. So this is a two-step equation, an old friend of ours. Do we know how to solve that? We sure do, right? Subtract 1 from both sides. Done this a million times. Get 3x equals 12, right? 3x equals 12. What now? Divide 3 on both sides. And what do we get? X equals 4, right? So what does that mean? That means it's the value x equals 4. So h of 4 equals 13. Let's take a look at this question. Let's say we have g of x, it's equal to 1 half x minus 3. Remember that means 1 half times x minus 3. And what if we were asked what value of x satisfies this condition? G of x equals 8. What value of x will give you an output of 8 if you plug it into this formula here, right? Well, that's the same as solving for this equation. 1 half x minus 3 equals 8, right? And we know how to solve equations like this. We're going to add 3 to both sides, right? Add 3 to both sides. Be left with 1 half times x equals 11, right? And how are we going to get x by itself in this case? Let's remember, we want to multiply by 2, right? Multiply by 2 because 2 times 1 half is equal to 1, right? And 1 times x is just x, and that equals 11 times 2, which is 22. All right, so what does that mean? That means g of 2 equals 8. Excuse my mistake there. That's not what it means. It means g of 22 equals 8. Right, guys? Sorry about that. G of 22 equals 8. All right, guys, we've got a bit of a whale of a problem here. Let's see. F of x equals 2 times the square root of x, all divided by 3. And it has a restricted domain with two values of x. Think back to a couple lessons ago when we talked about restricted domains, right? If we look at 2 times the square root of x divided by 3, there's a lot of different numbers we could plausibly plug in for x, but sometimes you can have a restricted domain. So and this is one of those cases. We're just told that we have a restricted domain with only two values of x. So for this problem, there are only two values of x that we're going to be allowed to plug into f of x. Let's read on. The range of f of x with this restricted domain is 2, comma, 10 over 3. What are the two values of the domain? Okay, guys, let's take this a step at a time. Let's remember what this means first, right? What does this mean? What is a range again? The range is the set of possible outputs of the function, right? So that means this function has two different outputs over this restricted domain. It has an output of 2 and it has an output of 10 over 3, right? So that makes sense, at least in terms of there being two values of the range, because we're being told that there are only two values in the domain. So let's call the domain before we know what the actual numbers are. Let's just write it out. Let's have our squiggly lines. There's going to be one value of x. Let's call it x sub 1. And there's going to be another value of x, right? Let's call it x sub 2. We don't know what these values are yet, but we know they're x values, and we know they're the two values of the domain, okay? And we know that one of them, if we take it and plug it into f of x, we'll get an output of 2, right? And we know that therefore the other one, if we take it and plug it into f of x, we'll get the output 10 over 3. Okay? So what does that mean? Well, let me erase one of these two equations for just a minute. Let me erase this, and let's just focus on technical difficulties. There we go. Let's just focus on this equation for now, okay? So f of x sub 1 equals 2. That's the value of the domain, which is going to give you the output of 2, so this value in the range. So that means that 2 times the square root of x sub 1 divided by 3 is equal to 2, right? Well, we know how to solve equations like this, right? We can start by multiplying by 3 on both sides, right? What are we going to get as a result of that? What's left on the left-hand side is 2 times the square root of x sub 1 equals 6, right? And what should be our next step? Well, let's divide both sides by 2, right? So finally, this factor of 2 will cancel out, and we'll have the square root of x sub 1 equals 6 divided by 2 is 3, right? So now let me just make a little bit of room over here. Let me make some room here, okay? And if the square root of x sub 1 equals 3, okay, if we have here the square root of x sub 1, how can we undo the square root sign, right? Well, we can take the square of both sides, right? We'll raise both sides to the second power, and that'll give us the fact that x sub 1 is equal to 9, okay? So this means the value x equals 9 is the value that produces the output 2. So that has to be now one of the values in our domain. So we found one value of the domain, and it is equal to 9. So therefore we know that the second value in our domain, x2, must be the value that when we plug it into f produces our second output, 10 over 3, okay? So that means 2 times the square root of x sub 2 divided by 3 equals 10 over 3. All right, let's solve this. We're going to multiply by 3 on both sides, okay? And in fact, on both sides, that multiple of 3 just cancels out the factor of 3 in the denominator on both sides, right? That means that 2 times the square root of x sub 2 is equal to 10. Okay, let's divide both sides by 2, right? We're going to get the square root of x sub 2 is equal to 10 divided by 2 is 5, right? Okay, so if the square root of x sub 2 is equal to 5, we can get rid of that square root sign by squaring both sides, right? And finally, x sub 2 is equal to 5 squared, 25, right? So therefore, the value x equals 25 produces our second output in the range 10 over 3, and therefore our second value of the domain must be 20, must be 20. Technical difficulties, guys. There we go. Must be 25. All right, so our restricted domain is 9 and 25. And the input 9 gives you the output 2. The output 25 gives you the output 10 over 3. So with the restricted domain 9 and 25, you get the restricted range 10 sorry, 2 and 10 over 3.